Or
Okay.
instructions for GeoHA1. Preparation assignment. Did you try to do the preparation assignment at all? I think you were busy yesterday.
Yeah, I haven't looked at it yet.
Okay.
So, but the extension problems, like from what I saw, it just looked a little bit like what we've already been doing, I think.
Yeah, there's just like added complications with it and stuff, but technically it's the same. It's just polynomials. Playing around with it. So it says here, I mean, we should just talk about most of the, but we're going to skip that. Do you know anything about the U substitution and stuff? It's just pretty much substitution.
Yeah, I looked at that like for a couple minutes before we started it.
Uh-huh.
And it just looked like you just put U in where the, like if there's repeating X bits.
It's just useful sometimes for the rational numbers. Please don't use not required. Yeah, solving can be done without it. Yep, true. Have you tried any of them at all?
Not yet.
Most of those top ones you probably are familiar with already. Most of them are probably familiar.
Yeah. That's a lot though. I feel like she's trying to lengthen everybody's meetings.
I feel like that too. But actually this one is actually wants more practice. The hardest one here is probably number 2, like question number 2.
Ooh, yeah.
Because I don't remember anything about conjugate pairs. I don't remember any of that from the
wait, conjugate pairs.
I remember it's vaguely familiar, but like,
hold on, I will look that up.
Yeah, because I'm looking it up right now, and
I'm not chemistry actually, so thanks.
E-text. I'm just going to use the search function on this textbook. So did no one reply to you at all as well?
Yeah, no one said anything. So.
Okay. Today was the last day of dropping it, I think. Let's see.
I was tempted.
Yeah, definitely. Yeah, I don't see any conjugate pairs. It's in chapter 3. Second degree polynomials. Oh, because it's the imaginary numbers. So I'm going to look at that question. We could say that this has a real coefficient, I guess.
Wait, but how would that have anything to do with conjugate pairs? Hold on.
Because it has the conjugate pair theorem, because it's the imaginary numbers.
Yeah, but it says, I just looked it up and it was like, conjugate pairs occur, if the coefficient minus the imaginary number is a 0, as well as the coefficient plus the imaginary number. Has to be 0, too.
I'm looking at this and it looks like if we use the example number 2 on the e-textbook,
Mm-hmm. Go there. Sorry.
it's x2, or because we have number 2, right? Like a 0 of x, or a 0 of 2, so that's x minus 2. And then we have the conjugate pair. Find a polynomial with real coefficients. So technically, our roots are 2, 1 minus I, and 1 plus I. So those are our roots.
So there's 3 then.
So we have 3 roots total. So what we can do pretty much is just write them down. So it would be x minus 2, x minus 1 minus I. So that's in brackets. And then x minus 1 plus I. So those are our roots, if that makes sense. And I guess we just put them together, because that would total to 0. Does that make sense?
Yeah, that makes sense.
Yeah.
Okay, cool.
And then we just put that together, I guess. Yeah.
Yeah.
Mhm. Yeah.
Cool. That works.
That's not as difficult as we thought.
Yeah. I was thinking it's all complicated. No, it's just easy. All right. Okay. So the first one, do we want to go through all of them?
We could go through the more difficult looking ones, because the top
Alright.
one, if we move 12, we just do the whole synthetic division.
Yeah.
I feel like we can get it.
You know, I
And then
finally figured out synthetic division, like the day before
Yeah,
the
that's
test.
good.
It was great.
That's good. That's perfect. That test was hard.
Yeah, that was a lot.
Yeah. So the second one. This is probably my first class with like a written portion of an exam.
Yeah, I've never had that, but I assume that since it's kind of hard to put in like all the
Yeah.
math stuff online, like I get it.
Yeah,
But
it's
it's-
crazy. I had a
Okay.
rough time with that one. But yeah, so we can do the second one with the 5, the
Yeah.
5th degree. Trying to walk through it. I feel like if you remove the x,
Yeah, I would do that too.
is it the x? Yeah. If you remove the x, then you would have x4 plus 3x squared plus 2 equals 0. And then you could probably factor that, because right now we have x equals 0.
Mm-hmm.
X squared. X squared. Plus 1 and then plus 2. So then it would be x is equals to the square root of 1. Oh, square root of negative 1. So that would be
So
I. That would just be I, right?
yeah.
Would that be plus minus I?
I think so.
Yeah, I would just put plus minus I. We can check later. And then there's the x square root of 2 plus minus. Yeah, I think that's it for that one. Let me check. X equals 0, yep. Sweet. Were you able to get that?
Hold on, where? Okay, I always have issues with the key, finding a key anyway. Just gotta check. Yeah, I got that.
Yeah, sweet.
Okay.
So that square root one looks difficult.
This next one, so number
Yeah.
3.
Yeah.
Okay.
I feel like I've used more paper in this class than my whole
Yeah.
college career. Square root 2x plus 1 taken away square root x is equals to 1.
Could we square everything?
I think we could.
Just to get rid of those, because that looks kind of difficult, and I feel
So
like it'd be a lot easier.
Would we move? I could try. If we square this, square that. So we would be with 2x plus 1 minus x. It would be plus minus x. Oh no, it'd just be minus x is equals to 1 squared, which is 1.
0 is a root there, right?
Okay, I actually don't know. Because if I move this here, that would be 0 is equals to 2x minus x. And then we would just have, what's 2x minus x? That's x.
Yeah.
X equals 0.
Yeah.
Just 0 though?
I don't know. Would there be another root there or not?
2x. Let's read.
Because I feel like with the square roots that there's going to be some, like a number that you could put in there that would give you another 0.
Yeah. If we move x, 2x plus 1, if we move that square rooted, so it's positive, does that change it?
It's 4.
The answer is 4?
Well, I was just randomly like putting numbers in starting at 0 that might work, and it's 4. Because if you do 2 times 4 plus 1 is 9, take the square root of that is 3, minus the square root of 4, which is 2, so 3 minus 2 is 1.
Oh, you just plugged in numbers for x.
Yeah, I don't think that I'm supposed to do that, but.
Well, that works. That's how you check. So if it's 4, then that means there's got to be squared 2x plus 1 is equals to 1. How does that work?
Okay.
Oh, because if it's on the other side, you would have to do it twice. Does that make sense? If we move that x, that square root of x to the other side, if we square root it the first time, it would be all of it. So then we would have 1 plus square root of x, 1 plus square root of x in brackets. Like twice, you know what I mean?
Yeah.
So it'd be 2x plus 1 is equals to bracket 1 plus square root of x, bracket 1 plus square root of x. Then simplify. 1 of 1 is 1. 1 square root is plus square root of x plus square root of x plus x. So that would be 1 plus square root of 2 square root of x plus x is equals to 2x plus 1. Does that make sense?
Yeah.
So then you just cancel the 1. I think, because if you move that, that's minus 1. Yeah, 2x is equals to 2 square root of x plus x. If you move the x, it would be am I doing this right still? Yeah, it would be x is equals to 2 square root of x. Now we can square root, or square it again. We can square both sides. So this would be x squared is equals to 4x x equals 4.
Okay, good. So there's a way to get it that is not just guess and check.
Okay, I guess it's just separating the squares or the square roots. I don't know if that's like a law or something.
Maybe. How do you do fraction exponents?
Am I back?
What?
My computer froze.
Oh, sorry. I was looking up fraction exponent.
I was trying to explain to you and then it froze.
Oh, I'm sorry.
So when you know how when you divide and the top number is the same as the bottom number, it just cancels out. So
Mhm.
if you square it,
Mm-hmm.
then the square cancels and then the bottom square cancels, or the divided square, if that makes sense.
Oh, okay.
So if we square both sides, it'll cancel out the bottom.
Okay.
I don't know what to do with the negative exponent. Does it say anything? So I know x, or where are we again? X2.
Negative exponents. Oh, I remember that. With negative exponents, all that you do is you do 1 over whatever you're taking the exponent of.
Oh, so it'll be 1 over x or x minus 2, right?
Yeah, 1 over x minus 2 to the 5th.
To the 5th. Okay. So if we cancel out the 2, it will just be x minus 2 to the power of negative 5 is equals to, what's 32 squared? 1,000. Wow. And then if we do that thing that you're talking about, And it would just be 1 over x minus 2 to the power of 5 is equals to 1024. And then we just multiply that over, I guess. 1 equals 1024 times x to the power of 2.
With fractions like
Good.
that, though, did we have to do that with squaring both sides? Or could we have, because I was reading that in any order you do the top number and in any order you do the bottom number. So could you just do, like, take away the 2 from the 5 and just have, like, x to the third?
No, I don't think so.
Oh, okay.
Because then you'd have to do anything to the other side too.
Yeah. All right.
So with this, I don't know if we're supposed to expand that fifth fraction at the bottom.
I'll see. Okay.
Because if we move it, we'd still have to expand it on the other side. That's rough. X minus 2. If you have 5 of those, you would have a 5th degree x. Let's see.
Oh gosh, I'm getting lost. Oh man.
You know how we have the x to the power of 5 now? Like x minus 2 to the power of 5.
Yeah.
We would expand. It would be written the same as x minus 2, x minus 2, x minus 2, x minus 2, x minus 2.
Yeah, I'm
So
just trying to do that.
Yeah, that's the part. 1 over that. So it's. I would do 2, and then it would be the same as the other 2, and then there would be 1 left. So it would be x squared, take away 4x plus 4. X squared, take away 4x plus 4, and then x minus 2. I just multiplied it. That's a long number. X plus 16. Oh, wow.
Okay.
X minus 2.
We have to be doing this wrong. This is such a big number.
Hopefully it's correct. X 16 3. Take away. Okay, I have a number.
I'm not there yet. I'm almost there.
Okay. Or no, I mean I had a number for the bottom.
Yeah, I'm almost there to that part.
X5. This is a big number. Wow. Oh my goodness.
Okay, hold on. X for 5.
That is huge. Is equals to 1024. What? How does that even work? There's no way I'm multiplying all of that in.
Okay, what'd you get for the bottom number?
X to the power of 5, take away 2x4, take away 10x4 plus 40x3, take
Wait,
away
40x3.
40x to the power of 3.
Yeah, where'd that come from?
I got,
Did I?
because
Did
got,
I do that wrong?
it might have been one of the signages, because I have, for my cube, I had 24 and 16. Did I do that? Yeah, that's 24 and 16. I added them.
All right.
And then did you get negative 80x squared plus 80x, take away 32?
Yeah. The rest of that I got. I just missed the
Top one.
good.
Hold on, let me just see.
Now, how do you? Can we do synthetic division for that?
We're trying to figure out right now. That would be ridiculous. I'm gonna check the answer real quick.
How? How is that the answer?
I don't know.
Where did that come from?
-5/2. That's correct.
Can we message her about that?
How does that work?
Because I have never seen a problem so complicated in my life.
Yeah, most of the problems she gives us are way complicated. But you're. Um, how? The problem is, even if we message her about it, we won't get it right away.
I wonder, is there a way to graph that? Because I just kind of want to see what that looks like on paper. That seems like a lot.
Yeah. Well, it makes sense though, because then it's a big number on the other side.
Mm-hmm.
So if we move it to the other side, all of that should equal to 1. So would that mean, how do you even go about doing that? Yeah, I have no answer. That's way too much. There's no way. That's -2. What? 9/4, man. Yeah, I think we just multiply all that in and it should all equal to 1.
Oh.
But that would take forever to do. Yeah, you would have to use the rational theorem. Did you try it?
Trying it. I'm not getting it.
Yeah. Well, I got as far as you multiply 1024 with all the numbers in the numbers. And I guess all of it's supposed to equal 9/4. somehow, if I multiply all those numbers in, it'd be like over 10,000 for that second number. It's all supposed to equal 1.
Yeah, I'm doing this wrong. That's okay. I will look at it later.
I totally don't get it either.
Okay.
Absolute values.
Now let's just do the absolute value one, and then we'll be good, I think.
Yeah, the other ones. Now it looks like you could use the switcheroo thing.
Okay.
I hate the rule for this. It'll be if it's
What is the
X-
rule for this? Because I feel like I can do this problem logically in my head, just given the relationship between the two numbers.
Yeah.
But I feel like I shouldn't do that because I feel like there's a way I'm supposed to do this
I feel
problem.
like it's one of those tricky ones.
Yeah.
I think I did one where it's like the equal is supposed to be negative or positive. Like you're supposed
Yeah.
to do this. So it would either be x2 minus 6 is equal to negative 5x or equals to positive 5x.
Well, I think it would be 6 for one of them. Sorry, I know I shouldn't do that.
Did you do that plug in again?
No, I just did it in my head, actually.
Oh. If I do it this way, it would be
Just because it has to come out, the only square that I could think of that comes out when you subtract 6 as ending in a product of 5 would be 36, and so that's just 6.
yeah. I'm just worried because the X on the other side as well.
Oh, 1 might do it too, actually. Hold on. Yeah, 1 works too. That's bad. I shouldn't do these in my head. Oh, I'm right. Cool. That's great.
So how did you do that? You just
Well, I was just trying to think of squares that if you subtract 6 ended in like a
if
product
the
of
last
5.
is 6, right?
Yeah,
Like
so
C,
6,
yeah.
6 and 1 work.
6 and 1 work. Yeah, I can see that. Okay, I see. That works. Because with this way, I got x is equals to negative 1, and then x is equals to positive 6.
Yeah.
And then the other one is negative 6 and positive 1.
Well, yeah, you could do negatives for both of those.
Yeah.
It doesn't say
I-
that on the key, though.
Does it have plus or minus or no?
It doesn't have anything.
Okay, so it might just be that.
All right.
Since it's
Cool.
absolute value. That
Holy
works.
crap.
That's annoying.
Sorry. We were
What's
supposed
that?
to get a storm tonight, and I guess it just hit.
Oh, finally?
Yeah.
That's crazy. Was that thunder?
Yeah.
Oh, okay.
Well, because my lights flickered for a second, and I was like, what was that? And then all this thunder. So, all right. I guess we better finish up before my Wi-Fi goes out.
Yeah. I guess. Should we do the thing on Thursday or tomorrow? The quiz.
I like Thursdays. Thursdays are good.
Okay,
If-
that works.
If you want to do Thursdays, because Wednesdays for me and Saturdays are the big homework days where everything's due.
Yeah.
So
I can do if no one else is going to say anything. We can do Tuesday.
yeah, that's good.
I think
All right.
we can demand it.
Hey, cool.
Okay. Are you going to submit this one then?
Yeah.
All right. Thanks, Madeline.
Thanks. Bye.